I'd like to introduce Judy Geyer, who will begin our program for today. Thank you.
Hello, everyone, and glad you all were able to join us today for the second presentation in this series, Climate Change, What Does It Mean for Floridians? Today, we'll hear what's needed to provide food security from our agricultural systems. But before the introductions, I want to remind you of the book Carolyn spoke about last week, Florida's Climate Changes, Variations, and Impacts, a product of the Florida Climate Institute, of which she is a coordinator. The 20 chapters in that book are organized into three groupings: societal challenges, economic and environmental challenges, and physical climate, past, present, and future. This course, the one we're doing now, addresses 6 of those 20 chapters. You can download that book free by going to, going to the Florida Climate Institute website. If you're interested in learning more about those 14 other topics. And now I'd like to introduce Carolyn Cox, who is coordinator for the Florida Climate Institute, to introduce Dr. James Jones. Carolyn.
Thanks, Judy. Welcome, everybody. Good to see you all again. It is my pleasure to introduce my previous boss and all-round excellent human being, Dr. Jim Jones. He's a distinguished professor emeritus at the University of Florida. He received his PhD in biological and agricultural engineering from North Carolina State University. Keep in mind, this is the short bio, folks. He is has a list as long as all of our arms combined, but I'll keep it short with his abbreviated bio here. So he is internationally recognized as a leader in mathematical modeling of cropping systems, interactive effects of climate, soil, water, genetics, and management on productivity, climate risk management, resource use efficiency, decision support systems for agriculture, and the integration of biophysical and economic models at farm, national, and international scales. He has developed and led various national and international transdisciplinary research programs, including the development of the Florida Climate Institute, consisting of 10 Florida universities, and the co-development of the Agricultural Model Intercomparison Project, which is now global and just about on every continent. Recently, he served as program director at the National Science Foundation in Chemical, Bioengineering, and Environmental and Transport Systems Division of the Engineering Directorate, where he co-led the multi-directorate funding initiative, Innovations at the Nexus of Food, Energy, and Water Systems. And he helped develop a new cross-directorate funding opportunity called Signals in the Soil. He currently serves on the National Academy of Science, Engineering, and Medicine Board on Agricultural and Natural Resources, and is leading the board's development on a study of strategies for transforming food and agricultural systems. Dr. Jones has published over 500 journal articles, authored or edited 5 books, and has taught short courses on agricultural systems modeling in countries worldwide. He has received many awards and recognitions and is a member of the National Academy of Engineering and a fellow member of AAAS, ASABE, ASA, and SSA professional societies. So without further ado, Dr. Jim Jones.
Thank you, Carolyn. I'm going to go ahead and share my screen now. Let's see. Let's see if I can get it in full screen here. I hope you can see that.
Yes, it looks great.
Okay. Well, anyway, thank you for hosting this this course, and I'm really excited to be here. I've been actually retired 3 times now, so but I'm still flunking retirement, Carolyn. Jean tells me I'm still flunking in all the things that I'm still doing, but it is interesting to stay involved, and I enjoy it and appreciate the opportunity to come here today. Now, the title of my talk is pretty broad, and so I'll be very broad. I won't give you a lot of details on different things, and I'll explain why later on. but it's about transforming food and agricultural systems, because I really believe that our current food and agricultural systems have to be transformed. Now, I've got a footnote on that one saying that transforming agricultural systems. I've given talks at the National Academy of Engineering and the National Science Foundation on this, and I say, well, transforming agricultural systems, it's really not rocket science. It's just a lot more complex than that, and it really is. I mean, if you think about the diversity of crops that we have in Florida and all of the differences in the technologies that they use, you know, so you think about changing any one of those and dealing with all the people involved in the food chain or the product value chain, it's just really, really complicated. But I'll talk a little bit about that, and I'll hit some of the broader issues about the importance and some of the technological advances that have occurred already, as well as some grand challenges. And then I'll focus a little bit on climate change impacts and adaptation. And then I'll switch to mitigation and what can agriculture and food systems do to help reduce the climate change, and some of the national and international initiatives that are going on to begin this movement, which hasn't really happened that much in the US until now. And I'm helping to lead several of those initiatives from the University of Florida in my different capacities. And then talk a little bit about some of the pathways for transformations. Oops, wrong way. So, importance. Food and agricultural products are essential for human survival. And it's really a major national security issue. And I think all of you who went to the grocery store during the peak of the COVID-19 pandemic could realize that, okay, what's wrong here? We're missing some food products. We're missing toilet paper and paper towels and things that are provided from agriculture and food production systems. So we could see that our food systems were extremely sensitive and were disrupted to some extent from the pandemic. We even had crops in Florida that were left in the field and were plowed up or just left standing there. And the thing about it, I mean, climate change is similar to that. It's creating already some real challenges to production and threats to some of the food chains and product value chains that we have. It's arguably the most sensitive sector of all of our sectors to climate. It's highly risky, and it's due to the uncertainties in climate as well as other factors, including market and environmental concerns and pandemics and other things. But if you look around the state, you'll see that around the country or the world, you'll see that agricultural and food systems have adopted to climate in the places where they're produced. And they've been fairly steady in terms of the places where crops are produced and livestock are produced over years. So they've basically adapted. So they know how to do this. They're always changing rather slowly in some cases, maybe a lot more slowly than is needed, we think, now. But they're very vulnerable to shocks, weather, pests, policy changes, markets, and it also contributes to the climate change problem. We contribute in agriculture and our food systems entirely about 10 to 20% of the total greenhouse gas emissions, and therefore they negatively impact the environment, not only the climate, but also water resources, soils, biodiversity, and they also have an impact on human health. Agricultural systems have had major and impressive advances since the 1930s. One of the graphs on the right shows the corn yield over that time period, and it's just linearly gone up due to technologies. And you saw this, you can see the steady production levels back early in the century, and this is about 1940 or 1950 when the yield started increasing. It's really important. It's helped us really keep the supply of food and other products in supermarkets in our value chain. Science and technology innovations have enabled these achievements. They're impressive genetic capabilities now. We know the genetic makeup of the different plants, even the different varieties, and plant breeders can modify these and select them, breed them to do all kinds of things. And even genetic engineering can modify inserting genes into the germplasm to have it be resistant to pests and diseases or to weeds. Fertilizers, management, automation, sensors, information technology, and also innovations in our businesses. There's also been favorable incentives and policies designed to increase and stabilize affordable food supplies. I think a year or last year or 2 years ago, the US government provided over $20 billion of incentives through different programs, national programs, to help agricultural industry. And that's really to produce the food and make sure that it's more stable and affordable. But these impressive gains, and they have been really impressive, they've occurred without adequately considering the external effects, degradation of water that's taking place, soil and atmosphere, the greenhouse gases that are emitting, the destruction of forests, the destruction of biodiversity, decreasing biodiversity. So, and more people are beginning to realize that, including a lot of companies and also consumers, and they're demanding more. And the companies are taking heed of this. And so we feel that now the food and agricultural systems are at an inflection point, and they face all these challenges, but also opportunities for changes. And the images I have along the bottom there are things that are actually happening even at the University of Florida. Molecular plant breeding, technologies for irrigation efficiency improvement, and water management, sensors for measuring the spatial variability of our production systems, so that every year you can have a record of how much the yield was in every square meter of soil. Drones, agroclimate. This is one of the products that we developed as the Southeast Climate Consortium that was jointly funded by NOAA and also through support from the Congress. And that's still available now. So you may want to go there and look at some of the tools that are available to help farmers and water managers, for different crops. Picture strawberries there. This is used to manage strawberry diseases and tell them how to optimally apply fungicides associated with climate variability. Some of the challenges that we're facing, though, is that we see our population is still increasing. By 2050, this means that we're going to need to add between 70 and 90% more food. And we have to do this in the same time where we're having limited and declining natural resources, such as fresh water. Arable land is being taken over by cities or other uses. Fossil fuels, phosphorus is limited, becoming more limited worldwide, which is an essential fertilizer. biodiversity. And for example, now we use about half of the habitable land and over half of the available fresh water for agricultural systems. Highly vulnerable to climate variability and climate change. And then the other thing that kind of is a big factor is that we lose between 30 and 50% of the food that's produced, and it goes into the food chain. And a lot of that's done at home, where we buy food and we don't eat it in time and we toss it away, or restaurants, or schools, or other things. And then our degradation of water. And so the grand challenge is really to meet these food and other product demands under changing climate, which is stressing food production, and changing demographics, while also protecting the environment. And that's one of the big challenge that Charles Godfrey, who's visited the University of Florida several times from the UK, has written about. So in Florida itself, agriculture is really important industry. It's second only to tourism in terms of the economic value, and it's over $120 billion in revenue per year to the state. And it supports about 2 million jobs. So it's really important economically to our citizens throughout the state. Florida has diverse climate conditions, from north to south, and they're suitable for many crops. So we grow over 200, I don't remember the number now, but over 200 crops and livestock and seafood. And the current temperatures where these crops are grown are near optimal for those crops. But climate change is going to affect that. Climate change impacts, we have higher temperature. That's we're very confident that that's happening. Sea level rise is happening. We have more and more strong climate events. And the impacts that impact crops, livestock, pests, and disease outbreaks, and water availability. So all of these things are simultaneously affecting how agriculture and food are produced and are used. Now, one thing that's positive about it is that as CO2 in the atmosphere does increase, this is a stimulant for crop growth. Crops take carbon dioxide from the air, large amounts of it, and they convert it into simple sugars through photosynthesis. And then these simple sugars are then converted in the plants to proteins and fats and stems and other tissues that produce the crops that we produce. And so adaptation, there are many new technologies that are coming around to do that. But I'll have to say here that in Florida, there are many knowledge gaps that exist. And if you've read that chapter on agriculture and forestry in the climate book that Judy just pointed out, you'll see that Florida hasn't really done very much at all on assessing the impacts of climate change, the adaptation possibilities and costs and risks, or on the mitigation. And that's in contrast to California. The graph on the right is actually one of my former students who published this in 2018 in California. And it shows there the simulations using models like those that we developed here at the university to predict what the impacts of those climate conditions will be in the future, taking the climate projections from the climate models and then running those through different times to see how the crop changes over years and over that duration. And for example, in the first graph on the upper left is alfalfa. Doesn't affect that one very much. But you get down to cotton and sunflower on the bottom, and even wheat, you see that there are major decreases as time on the horizontal axis goes between now and 2050 and all the way out to 2100 in terms of what the impacts are likely to be. So, and I wanted to show this because I won't show all the different interactions that occur, but since temperature is so critical, and Dr. Ryan showed this same curve last week showing how temperature is so critical for development of mosquitoes. Same is true for plants. And so this curve, I think, may be for corn, but you'll see that its optimal temperature where it peaks out is around, I don't know, about 85 degrees or 86 to 87 degrees Fahrenheit, or about 30 to 31 degrees Celsius. And if you have cooler temperatures, it drops off dramatically. And there's a lot of data on this to show this for all of the major crops that we have. And they all follow that same curve, but they're not all in that same position. For wheat, this whole curve is shifted to the left. It's adapted to cool temperatures. And I'll show you an example of that in a moment. Beans, for example, like frijoli beans, are intermediate between corn and wheat. And then there's some that are even cooler, more cooler adapted than wheat. And you'll see the dashed line, excuse me, on the upper part of that graph. Most experiments have not really considered the higher temperatures. And so there was a lot of uncertainty there. And some of the work that we did at the University of Florida was to try to get data on the effects of those higher temperatures on some of the crops that we were working with. Before I get to that, though, this is showing the case in Florida. This actually shows the red curve there shows the temperatures increasing and then decreasing again in Gainesville by month. And it goes, it goes between maybe 12 degrees Celsius or 55 degrees Fahrenheit, all the way to a peak on that, a daily average of about almost about 80 degrees. And then it goes back down. And I've superimposed here the peanut growing season that Gainesville has. I mean, this is the season when peanuts are grown. The wheat is actually grown in the wintertime. It's because it's more adapted to cool temperatures. And and other crops are grown, like strawberries here in Plant City, are grown during the winter months because they're very well adapted to cool temperature, and the markets are good during that time because California can't produce them during that time period. So if climate changes, that red curve is going to shift up. And that means that, okay, maybe suddenly it's going to be too hot to grow peanuts here. And we'll have to move or adapt to that, or by breeding new varieties or changing a crop or something. And I'll go through those in a moment. But this is some of the data that we collected in Gainesville. This is from Ken Booty at the University of Florida. Myself and others did this. We had these outdoor controlled environment chambers that we designed and built there that can control temperature but get the same sunlight. We can control water and humidity and CO2 concentrations to mimic climate change conditions. And you can see that the yield of this crop, this is beans, goes down dramatically once you get above 24, 25 degrees Celsius. So that's information that we then used to upgrade our models so that we could use them for these climate change studies for hot conditions. Water is the same way. I mean, if you have water limitations, drought, it's a dramatic decrease in productivity from maybe more than 50%, depending on drought. And so we occasionally have droughts here in the state, and we have a sandy soil. So a lot of irrigation takes place here in Florida to supply the crop needs while the rainfall is not providing it. And these things are put together. These fundamental relationships between water use and its effect on photosynthesis and growth, and on temperature, on development and photosynthesis and dry matter production, are all put into our dynamic models that are then used to study climate change impacts. And some of you may know Bruce Curry, who is there in the village in Gainesville still. And Bob Peart and I and Ken Booty worked on the first climate assessment in the US. And we used these models back in the 1990s to study the impacts of climate change on agriculture across the US. This is again the figure from California. Now, what can be done about this? I'm not going to go into detail, as I said, but there are a number of things that can be done to adapt to these changes in climate. And I've listed them here. So you can shift the time or the duration of the growing season by varieties, changing varieties. Or you can change from planting in November, you can plant in the springtime. You can change crop varieties or animal breeds that are more adapted to warm temperatures. Diversify the enterprises. You can try to use adaptive systems that uses tools like the decision support systems, agroclimate, and climate smart systems. Obtain insurance for the chances that particular years are going to be too hot or too dry. You can breed, although this breeding takes a lot of time, to breed new varieties or cattle breed, livestock breeds. Irrigate, I mentioned that already. You can start growing the plants inside instead of growing them outside and control the environment. Of course, that costs an awful lot, but people do that, even here in Florida. You can change enterprises from going from crop to forest. We've actually seen that when the freezes hit citrus. Here, some of the parts of the state that used to grow citrus converted to pine forest. Of course, there are economic implications to that, and you can also migrate northward. This is what's happening to some of the vineyards in France and Italy are moving north into England and Sweden. And here in the US, going into Canada. So those are some of the things that can be done. And again, it's complicated, and every crop or every enterprise is going to have its own pathway for adaptation. That's another reason it's so complicated. I want to talk a little bit about mitigation now, because that's something that we've more or less had to avoid talking about very much because of the political climate and so forth. But now maybe things are changing, and I want to talk a little bit about it to let you know what's happening. It's really exciting. As I told you before, our food and agricultural systems emit about 10 to 20% of the total greenhouse gas emissions. And as Dr. Ryan showed last week, these greenhouse gases trap the energy in the earth from the sun. It traps that energy, and it creates a hotter condition, warmer condition in the earth. So we want to reduce that. And so mitigation is all about how we can reduce the CO2 and the greenhouse gases in the atmosphere to reduce that. Well, agriculture can reduce it to zero, and that's significant. or it actually can reduce it to negative. It can actually store carbon in different ways, like in the soil. And therefore, it would start becoming a net positive benefit to the atmosphere, as opposed to now adding more fuel to the fire, so to speak. And the reason for this is that our crops, pastures, and forests remove carbon dioxide from the atmosphere in photosynthesis. And we believe that it is possible for crops and forests to remove more CO2 than it emits and help achieve this, this solution to the greenhouse gas problem. But can they be done at the same time? Can we adapt and mitigate the climate change at the same time, providing the food and other products and being more efficient users of natural resources? And if so, how? So that's the big question that we're tackling right now, is how to really do this. And this is where we need to transform. Our current agricultural systems evolved through incremental changes to existing systems to keep up with increasing demands and have a stable supply. Our mindset was to increase that production, but very little attention, some attention, but not enough attention to the natural resource base, the environmental impacts, and climate change until now. And so what we're doing, you know, we're by having all this energy loss, all this CO2 loss and other greenhouse gases, that happens primarily because we're trapping resources and not reusing them. Our food disposal, you know, we put it in landfills and that emits greenhouse gases. We don't use all the animal waste that are produced for fertilizers or other products and have a lot of carbon and other nutrients, other elements in there. You can produce bioplastics from it or energy. And so addressing this combined need is what we're trying to do. And I've drawn a schematic at the bottom of our current systems. And this is what I mean, a system. It's got production system, which is actually a subsystem. The products are transported to processing and packaging, and then to the supermarket, and then to the consumption phase. So that whole chain there where you've got inputs coming in, they're used in agriculture to produce products that flow along this chain. All along that pathway, we're losing materials. A lot of it is going into the environment and creating those gases. What would happen if we could capture a lot of those losses and use them productively? And so there's now interest in this. There's a new climate administration, new administration Climate 21 project. They want to enable forest and landowners to participate in carbon credit markets, where they're using their land and their agricultural systems and forest systems to capture the CO2 and store it in the soils or the other products that are produced. I just listened to a Senate Ag Committee hearing about 2 weeks ago, and they're proposing a Growing Climate Solutions Act to solve some of these complex problems and to help farmers and ranchers and foresters manage the lands that mitigate climate change. Some of the farmer organizations are getting into this now. I mean, the U.S. Farmers and Ranchers in Action, the Solutions from the Land group, and they have a joint effort with the University of Florida, Cotton Incorporated, and there are others. And there's major industry interest, including Microsoft and Google and IBM and others, as well as some of the more traditional food companies and John Deere's and other companies. So I think there's a convergence of this interest and resolve to do something that I think now is a really prime time for this to happen. And that's what I'm trying to help promote and pursue as well. This is a graph here on the right. I'll show you that first. It's showing what our current U.S. agriculture is doing, and it's about 9.9% emissions. Just by using the technologies that are available today, they could reduce that down to 3.8%. But it may cost to do it. And so there's no payment, for example, for ecosystem services to do that. Somehow farmers have to get paid for any way that they are, having practices that really promote the environment that they don't get an income stream from. And then the last part of that slide is that it shows that some feasible technologies that are under development right now could actually reduce that so that it's positive. You get a 4% gain or net capture of carbon out of the atmosphere. So up here is a list of all the societal goals. I mean, there are multiple goals. We want nutritious foods and other products. We want them to be available and affordable for the population. But we also really want to reduce greenhouse gas emissions and abate this climate change problem that we have. And our agricultural systems, food systems can contribute to that. We need to eliminate the contamination of our water and ecosystems. This is huge. I mean, there's a big dead zone in the Gulf of Mexico that's caused to a large extent by the nitrogen runoff from the Midwest agriculture. And but we also have to ensure that farmers and businesses benefit economically, or they won't actually perform those operations that are required to do these changes. Now, one of the approach that we're taking is a systems approach, and this is based on a number of studies by the national academies and by some of our own studies. The systems approach has been proposed in a number of national academy studies, but they didn't say how to do it. And so we're trying to provide that missing link so that this can actually happen. These food systems include all the way from growing and harvesting, processing, packaging, marketing, selling, and consumption and disposal of the food and food-related items. A lot of this is in livestock, for example, or the food waste that we get from grocery stores or our homes. And each one of these components, this set of arrows here on the left side of the graph depicts that chain that's more or less linear now. You don't really have resources going back or waste going back into production, which is what happens in natural systems. Nature is set up that, the loss from one part of a system is food for another. And we've broken that cycle in our modern farming systems. We don't grow livestock to a large extent where the crops are grown or where the feed is grown. And so since they're displaced, it's more of a challenge of dealing with the waste. In the olden days, when I was a kid, we used to feed livestock with our waste from our scraps from our table. And we ran them on pastures to help fertilize the pastures. But what we think we can do, and this is being researched by many other industries, and now agriculture is looking into it as well, is to make this more circular by capturing some of these losses and waste and effectively converting those into useful products so that they don't just get thrown in a landfill or put into the water and pollute the water and the environment. And it's a lot more efficient use of resources at the same time. So this is referred to as a circular economy, and that's a systematic approach to economic development that benefits businesses, society, and the environment. Inspired by nature, as I said earlier, and that nature's cycling of water and biological products sustains the earth. And we feel that sustainability of food and agricultural system would be an outcome of transforming these systems into more circular economy systems. And there are 3 principles that are used there in circular designs. One of them is design out waste and pollution. And any transformations that occur, make sure you take care of the parts where you're getting a lot of waste and pollution. Keep the products and materials in use. And then regenerate natural systems like our soils and our water resources. So the American Society of Agriculture and Biological Engineering took on a study starting last year of what it would mean if we transition our food and agricultural systems into circular economies. And so we came up with these different steps. We have to identify where the losses and waste are occurring and what they're causing, and then reimagine and rethink the design of these systems that would capture these and not let them be lost and wasted. And this requires a convergence of technologies and disciplines. So even though we did this in our agricultural and biological engineering profession, we realized that we have to have other professions coming in as well to provide the innovations in technologies, genetics, recycling, policies, and businesses in order to make this happen. And then also plan for transition. None of this is going to happen immediately. And the 2 images at the bottom are from a special issue that we published in Resource, just came out this month, on what this would mean for livestock systems, or what it would mean for tomato systems. And the one in tomato was led by Katie Migliaccio, who is the chair of the Agriculture and Biological Engineering Department at the University of Florida. So we had a number of those there, and Carolyn, I think we could, if not already available to them, we could make that available to Judy and the different people. These are short articles that just give an overview of how this might work. The private sector is ahead of us in academia. This is an image of one of the vertical farming systems on the right at the top. And there's actually a large one in Orlando, completely enclosed, and they grow these vegetables in layers, and they can produce large amounts of vegetables, greens, and radishes and carrots through this system. So anyway, they're actually moving ahead on this, and John Deere, Walmart, Microsoft, Land O'Lakes, Cotton Incorporated, Nestle Corporation, all of these companies are really pushing now the ideas of circular economies. Academia is behind, and partly because we haven't had support to actually engage in these kind of system-wide studies like we need to be. The National Academies, now there are 2 efforts underway there. One of them is a study by the Board on Agriculture and Natural Resources that Carolyn mentioned I was a part of. And also the National Academy of Engineering has a forum on complex systems. And I convinced them that food and agricultural systems are about the most complex one could imagine. And so this is going to be a focus of one of their programs now, and bringing in other engineers to deal with the chemical engineering, electrical engineering, and other engineering disciplines, as well as agricultural disciplines. At University of Florida, this is being led out of the Agriculture and Biological Engineering Department, the Department of Agronomy, Animal Science is involved as well now. And we had a national working group meeting to create this special issue. And that's the one I mentioned to Carolyn was available that you could have freely. And we also have a meeting on July the 12th, our annual meeting that has a number of different disciplines, 8 different professional societies coming together to explore how to work together to make this happen. I'm not going to go through this in detail, but if you're interested in this for corn soybeans, I worked with a colleague of mine at Michigan State University. I was actually on his committee too when he got his PhD at Michigan State. But we studied, okay, can we focus only on farming systems, extensive farming systems that are massive, they're technologically savvy, they have major pieces of equipment and global positioning systems that guide their tractors and map the yields. What can we do there? And we came up, with a transition plan for them that I presented to some of the farmer groups, and they say that this resonates with them, to do what we can now in the immediate term, 20 to 25, and then replace and reduce some of those practices that are wasteful or where losses occur, and also revise the incentives. If we're going to pay out that much money for agricultural and food systems, it should be, I think, it should be tailored toward also protecting the environment and help farmers play a role in this major problem we have. In the long term, there are some chemical and biochemical processes and genetic developments that are going on that are likely to be part of the package that will be used in the future. Those are going to take longer, but they have major implications on the amount of CO2 that would be emitted and also the amount of fossil fuel that would be used. For example, electrification of the Haber-Bosch process. About almost a half of the CO2 emitted from the corn production systems I showed a picture of is due to the conversion of nitrogen from the atmosphere into nitrogen fertilizer. A lot of energy is required, and so that emits CO2 and greenhouse gases. And if we can change that, then that will be a real help to the planet as well as to our industries. I mentioned this already about ASABE and other professional societies getting together. This is happening. The presidents and CEOs of the different professional societies have agreed that this is something we need to do. And then just in closing, I just wanted to say that I wish we had done more, and I could have shown you more about what's happening in Florida and what our possibilities are here. But stay tuned. I think this is going to happen, and take into account both the adaptation, which some of you may have questions about, but also the mitigation side of things that has been much less studied in agriculture. And this can be done by farmers. Many of them are eager to do this now. They may need incentives in some cases to get some of these changes happening. Timing is ideal now. There are many options open. And we need to invest in technology, management, incentive innovation, research and development as well. We need to get a convergence, not only of the industries, but also the academics who are looking for ways to help with these large scale problems. And so I'll stop there, Judy and Carolyn, and see if there are any questions. That's my last slide here, and I appreciate this opportunity again.
Thank you very much, Jim. Julianne, have you unmuted me?
Yeah.
Okay, you can hear me. Okay, good.
Yeah.
I see that there are 2 chat comments here. Let me go to those from Elizabeth and Bob Bernstein. For ag sustainability in Florida, how big a cultural change as opposed to technological changes are needed, particularly in the face of adding 900 people per day, land use restriction, question mark, recycling waste, question mark, less beef, question mark. And then I have a second one from someone else, if we have no one in the audience, in the Oak Group.
Okay, yeah, that's part of the complexity. I mean, we have to have a mindset change in the population and in policy, as well as technologies. Now, I will have to say that technologies are needed. For example, on the waste problem, we need to have neat technologies that enable all of us to be more conservative with our waste and not put so many in our landfills, and have a way to recycle those so that they go into industries that make use of those resources that are embedded in the food waste or the animal waste or the forest waste that are produced. So it's going to take a combination of both of those. And I don't know, it's maybe the chicken and egg problem, but I think if we had the technologies available, that more people through the value chain would be willing to adopt some of the necessary things. Even here in Florida, Florida's a bit more challenging than many of the other states, not only for the political situation, but also because of the diversity of the agricultural systems we have.
Julianne, do you have any questions there from the audience?
I do not have any here, so if you want to read Eli's.
Okay, I thought Emily Patton raised her hand. Can you unmute Emily, please?
I don't see her, but Emily Patton, you can unmute yourself.
Okay, can you hear me?
Yes,
Yes.
go ahead.
All right. I was wondering, a couple times you've mentioned storing the CO2 in the earth rather than releasing it into the atmosphere. What is that going to do to the soil? Will there be able, is it going to change the pH of the soil? Will you be able to grow things, or it's going to end up as a big dirt pile?
No, I mean, that's a very good question. But if you think about how we ended up with production agriculture today, this land used to be in trees or in prairies or pastures of some kind, and the carbon composition in the soils in those situations is much higher than it is in agricultural soils. And the reason for that is when we till the soil, we release we aerate it. And so a lot of the microbes that are in the soil will convert that organic matter, which is rich in carbon. It will convert it to nutrients and other biochemicals. The CO2 is released. And so carbon is decreased when we till the land. And so the crops would love it. I mean, by adding more carbon to the soil, it's an organic carbon that helps the soil hold more water. It helps the soil provide some of the nutrients without providing so much synthetic fertilizer. And it reduces runoff and erosion. So it's really a win-win situation for the soil case. And that's part of the regenerate natural systems. Try to make them the way they were before we till them and before we lost all the organic matter and the carbon that was in the soil to start with. Anyway, it's a good question.
Thank you very much.
Julianne, I have two items in chat. One from Ellie Glazer. Is circular farming the same as vertical farming? It is my understanding that vertical farming is 100 to 300 more productive per acre and 50 times better in its use of water, no pesticides, no washing from market. It also allows land to be conserved to better absorption of CO2. It is also useful for certain crops, however. Can you comment on my understanding and the possibility that vertical farming is worth developing, and can UF help perfect vertical farming?
That's another good question. And yes, I'm going to say yes to almost everything that was proposed there. The only problem with vertical farming, it takes an awful lot of energy. I mean, if you think about plants, I mean, plants have to have sunlight or artificially generated light. And every layer of that vertical form has to have the amount of light that it needs to produce photosynthesis, to produce the dry matter that goes into the lettuce or carrots or radishes or whatever is produced there. But it is true that the vertical farm that I've interacted with in New Jersey when I was at National Science Foundation, they've monitored their water use, and it's about, oh, I don't know, it uses about 5%, only about 5% of the water that's used in producing the same crop in the field. And yes, they're safer. You can treat these, keep out the pests and diseases, and so there's a lot of good things. And so if they solve the energy problem and all the greenhouse gases there, I think vertical farming will be play a big role in the future for our systems. And vertical farming isn't the only technology that's being developed. Some of you've probably eaten an Impossible Burger from Burger King. Okay, those also reduce CO2 emission. And now there are people in synthetic biology that are growing beef from cells, from animal cells. And so they actually produce it from culture. And they do the same thing for chicken or fish. And so that's really expensive now, but we have a chapter on these two topics in that special issue that I mentioned to Carolyn that she could provide for you. And you can read a synopsis of both the vertical farming and also the synthetic beef and synthetic chicken story there as well. And they do have an important role.
Okay, thank you. And I have a chat from Chris Martinez, who, by the way, is going to be our very last speaker, and he's going to be talking about water. So
Okay.
Chris, he says, Jim, you mentioned about the amount of food that goes to waste in our own homes. What about people that are home composters, where we reuse this waste to later add to our fruit trees and our garden beds? I certainly agree that it is still wasteful given that food was transported, stored, etc. Any idea on the reduction of waste in doing so?
Well, I think the use of composting and putting it back on their fruit trees and the vegetable crops that may be grown locally is a very good way of using the material that has been produced. So in that case, it's like producing a fertilizer. And so it reduces the amount of synthetic fertilizer that one would have. And I haven't done a life cycle analysis of that particular question yet, but I'm sure some people have, and they would show that composting is beneficial. It may not be as beneficial as some other techniques, many of which we may not have yet, but also not all of us can compost. Where I live now, we wouldn't be able to compost, although we've done that before. So each of these things, there are a lot of different options for people to use to reduce the impact on the environment, on climate, and also on the water resources. And I'm glad Chris is going to talk about that. He would be good. This study in California was done by one of our students, Chris, Tapan Patak. I forgot his last name, but anyway, he's one of our students.
Julianne, do you see any questions?
We don't have any here.
And as I scan the participants, I don't see any more. Oh, I see Richard Petway raising his hand. Richard.
Go ahead and unmute. There we go.
I just was kind of curious about carbon being inserted in the earth, especially in these dense pollution, dense areas of where we're having fracking, and when we're trying to preserve the pressure in the oil reservoir below. They're talking about secondary and tertiary pressure being inserted, putting water back into the soil to generate pressure in
Mhm.
oil pools. Is carbon possibly compatible with such development of pressure in the oil patch?
Well, I don't know myself. I mean, the process that I was referring to are things that farmers could do in the topsoil.
Right.
And by, if you look at the mass of topsoil around the world, and even in the U.S., the amount of topsoil that's there, if we could increase the organic matter and the carbon by 1%, we would be removing a massive amount of carbon from the atmosphere and putting it into the soil to refurbish that soil condition. So that's what I was talking about. If you're injecting carbon dioxide deeper in the soil, like in the fracking question that you asked, Richard, there are studies going on now. In fact, the National Academy of Engineering has got I think a workshop or a discussion session from different engineering firms on looking at ways to inject CO2 into the soil, and therefore, and deep into the soil, like the fracking issue. And I don't know if they'll be talking about fracking for pumping it down there, but I wouldn't be surprised if they're not. That sounds like a possible technology that might be beneficial. I don't know.
Thank you.
I have a question from Pat Harden. How receptive are Florida farmers to any of these changes in their current practices?
Okay, I mentioned that's another good question. I mean, it's going to vary across the board. I mean, all of us are individuals and we have different opinions about things and so forth. But I can say that there are a number of farmers in Florida who are eager to do things that are beneficial to the earth. I mean, farmers are already considered, and I think justifiably so, stewards of the land. Okay, I mean, many of the farms that you go by, I mean, they're just beautiful. They're laid out in very nice ways, and they're really aesthetic when you look at them. But they haven't really become stewards of the earth, and I think that's where many of them would like to go. They would like to be not only stewards of the land that they manage, but also the natural environment in the atmosphere and the water systems as well. But they have to have an income stream if they're going to spend their energy, I mean, their resources on doing that instead of their normal farming practices. So the group Solutions from the Land, and you can Google them and you'll see they're calling for a renaissance to farming practices, and they're talking about the same things. In fact, I'm on their senior advisor board. University of Florida has a project with them in which a number of farmers in Florida are participating in that. I haven't been part of that because that all developed when I was at the National Science Foundation. But Jack Payne, who some of you may know as senior vice president, helped develop that project from the vice president's office at the university. So yes, I think there will be some. There are always early adopters, and then people will see, well, they seem to be making more money, and so maybe I'll try that too. And it's really good for the earth, and everybody is the people who are buying our products will buy more from people who are good producers and follow those practices. And that's where the Nestle and the Walmart are coming in. They're putting a lot of pressure on the purchasing of their supplies that they sell in stores. They want them to be sustainable. And so you're getting this whole mixture of society that's converging around these ideas. And so I think farmers in Florida will be a part of this. Some of the farmers in Florida are already doing a very good job. I mean, the sugarcane industry in South Florida, they're taking all the waste that they produce and creating energy. They don't buy any electricity from the grid, and making sugar from the sugar cane. So
Thank you, Jim. I don't see any other questions or chats. Do you, Julianne?
No, nothing here.
Okay. Jim, thank you so much for your presentation, which started out as a little discouraging, thinking of all the things that agriculture has done over the past. But you leave us with some hope, some innovative things that are happening, not only at an academic level, but at a government level and also in the private sector.
right.
I really appreciate that. And I think Carolyn told me that she was going to sign off early. She had to be somewhere. So I will send you an email to get the specific reference on that resource that you talked about. So, and then I can share it with people here. Again,
Okay.
Jim, thank you very much. Stay well, stay safe, and hope to talk to you again soon.
Well, thank you very much. I really appreciate this opportunity. And like I said, I could have been an Oak Hammock neighbor. But
Okay.
anyway, I'm still there. And
Come on down.
I'm still there in spirit. Yeah, come on up. I'm still there in spirit anyway. So thank you again, Judy, for inviting me for this.
Thank you. Take care now.
All right, you too.
Bye-bye.
Bye.